Section 3.3 is going to be a continuation of truth tables. This time we're going to look at the conditional and biconditional truth tables. Conditional is the if P then Q statement, and there is only one time where the conditional statement is false. The only time that the conditional statement is false is if the first statement, the antecedent, is true, and the second statement, the consequence, is false. If that ever happens, then the conditional will be false. Any other time, the conditional is true. So let's look at an example. Construct a truth table for the statement, not P, if not P, then not Q. So I'm going to scoot this out of the way. So first thing we need to do when we start to do this is we need to make just our generic P column and our generic Q column. Since there's only two statements, there are only going to be 4 possibilities that you can answer P, Q. If you fill the P column in first, you'll have a true, true, false, false. And your Q column will be true, false, true, false. Then you need to find your antecedent, which is the left side, the not P. The not P is just going to be the opposite of the P column. False, false, true, true. Then you need to find your consequent, which is going to be the right-hand side, which is the not Q. The not Q is just the opposite of the Q column. False, true, false, true. Then you're able to do the biconditional. So you need to look at not P first, then not Q second. You do have to go in that order. If you do not go in that order, you could get the problem wrong. So remember, the only time that this turns out to be false is if you have a true first and a false second. So in our first case, we have false, false. So that would make a true statement. In our second case, we have false, true, true statement. Our third case, we have true, false. That is the one and only time the conditional comes out to be false. And in our last case, we get a true, true, which is a true statement. The biconditional is the if and only if. So P, if and only if Q. This is true only when P and Q have the same truth value. So they either have to both be true or they have to both be false. So if you want to write this table down, the options for your P's are true, true, false, false. The options for the Q's are true, false, true, false. And if you were going to fill in the P, if and only if Q, the only time it's false is when they have opposite truth values. So for case 1, true, true would be true. Case 2 would be false, and case 3 would be false because they do not have the same truth values. But in case 4, they're both false, so that is also true. So let's practice the biconditional. Let's construct a truth table for this statement. Not P, if and only if, not Q, if not Q, then R. Now notice the parentheses around the if not Q, then R. You need to find that whole phrase before you can complete the biconditional. So, since we have 3 statements, we have a P, Q, and an R, we're going to need 3 columns, P, Q, and R. And remember, when you have 3 statements, that gives you 8 possible ways to combine those. So under the P column, do 4 trues and 4 falses. I'm going to move this up just a little bit. Under the Q column, 2 trues, 2 falses, 2 trues, 2 falses. And under the R column, alternate true, false, true, false, true, false, true, false. Now, we first have to find our antecedent or the item that's in front. So we have to find not P first. Okay, so the not P will be easy. That's just going to be the opposite of the P column. So that'll be 4 falses followed by 4 trues. Then we need to find the right-hand side. So we need to figure out what not Q is going to be. I'm leaving a little space for a reason here. Okay, so what is not Q? Well, not Q is just going to be the opposite of the Q column. So that'll be false, false, true, true, false, false, true, true. Then we need to figure out if not Q, then R. And that'll give us the right-hand side of our biconditional. Okay, so if false, then true. Is that a true or a false statement? Well, that one, if the false comes first and the true comes second, that is considered true. If false, then false, true. If true, then true, true. And again, I'm getting these from that table about conditionals that I gave you a few minutes ago. If true, then false. That makes a false statement. If false, then true, true. If false, then false, true. If true, then true, true. If true, then false, false. Now we have to put the right-hand side and the left-hand side together. So we need to take not P, and we need to take if not Q, then R, and we need to do the biconditional of those two. So my answers, I'm going to write it in the middle. So if I have a false true, I get a false. False true is a false. False true is a false. False, false is true. True, true is true. True, true is true. True, true is true. True, false is false. And so this black column would represent the solution. Okay, so we're going to show you a graph on the next slide. And this represents the student population by age group in 2013 for the State College of Florida. We're going to use this graph to determine the truth value of some compound statements. So if you look at the graph, they have it split up by age group. Students that are younger than 20 is 44%. Students between 20 and 29 is 41%. Students between 30 and 39 is 8%. Students between 40 and 49 is 5%. And students that are over 50 and older is 2%. We're going to use that table to answer questions. We do not need to complete an entire truth table unless you really want to, but you should be able to do this without a truth table. So the first compound statement says, if 44% of the SCF population is younger than 20, or 38% of the population is ages 20 to 29, then 8% of the population is age 30 to 39. Okay, so first thing we have to do is we have to put that in symbolic form. So the first thing I notice is I'm seeing the if-then. Okay, so to me that means we're dealing with a conditional statement when I see the if-then. Next thing I notice is this comma that's hanging out there. So whenever you see a comma, that usually indicates a set of parentheses. And those parentheses are going to go before the conditional statement. So if I read before that comma, I see the statement 44% of the population. 44% of the population is younger than 20. I'm going to let that be statement P. Then I see the word or, so that's my disjunction. Next, I see 38% of the population is ages 20 to 29. That's going to be my statement Q. So P or Q. If P or Q, then, and after the then, I see 8% of the population is ages 30 to 39. That's going to be my R. Now, to avoid creating the truth table, what we're going to do is we're going to use the data that was provided before. Okay, so if I look at the data, the first thing I want to study is the population that's under 20. Okay, my population that's under 20 is 44%. And the first item said was if 44% of the SFC population is younger than 20. So that's a true statement. So I can give P a truth value of T. Now I have to figure out Q. Q is 38% of the population is ages 20 to 29. Okay, well that is false because it's actually 41% there. Okay, so now I know that P is true and I know that Q is false. So what does that tell me about P or Q? Well, in an or situation, only one of them needs to be true. So since P is true, I know that the left-hand side of the conditional statement is true. Now I need to see what's going on with statement R. Statement R is 8% of the population is age 30 to 39. Well, if you look at that wedge, that is a true statement. So in a conditional, if you get if true, then true, that turns out to be a true statement. So what they have said from the data that is collected is true. Okay, we're going to use this data again with a different question. So first statement, 5% of the population is age 40 to 49. So that we're going to let be statement P. And, so that is your conjunction. 5% of the population is age 50 and older. So we're going to let that be statement Q. Comma means you're going to have a set of parentheses around that first statement. If and only if, so if and only if is a biconditional. 41% of the population is age 20 to 29. So we're going to let that be R. Okay, so if I were to write that as a symbolic form, I'm going to need a set of parentheses, and I'm going to have P and Q. Then I need my if and only if, and then I need my statement R. Now we're going to use our data to figure out if P, Q, and R are true or false. Okay, so statement P is that 5% of the population is 40 to 49. So if you look at the data, that is true. Statement Q is that 5% of the population is 50 and older. That is false. We only have 2% there. So remember, when you're doing a conditional, a conjunction, they have to both be true. So if P is true and Q is false, then the conjunction is going to be false. Now we have to figure out if R is true or false. So R is 41% of the population is 20 to 29. That is a true statement. Now, for biconditional, remember you only get to mark that true if they have the same truth value. Well, in this case, we have a false and a true, so this statement that they've made is false. There's going to be some special terminology that comes up in this section. One is self-contradiction. A self-contradiction is a compound statement that is always false. So when you get to your final column in your truth table, the whole column will be false. If that happens, you have a self-contradiction. So for example, let me show you this problem. On the left-hand side, we have P if and only if Q. On the right-hand side, we have P if and only if not Q. And then in the middle, we are doing the conjunction. So let's develop the truth table and see what a self-contradiction looks like. So we only have statements P and Q. So we're going to have to make our 4 options there. Then we're going to have to come up with the right-hand side. P if and only if Q. Then we're going to have to come up with the left-hand side. P if and only if not Q. Then we'll come up with the conjunction. Okay, so let's figure out the right-hand side first. So the left-hand side first. P if and only if Q. So keep in mind that the only time this is true is if they have the same truth value. They're either both true or they're both false. Otherwise, it's false. Now, we also need to figure out P if and only if not Q. I would recommend you figure out what the not Q is before trying to figure out what the biconditional is. So remember, to get the not Q, you just need to do the opposite of the Q column. Then to do the conditional, you look at the P column and the not Q column. And remember, biconditional is only true if they have the same truth values. Okay. Last, you need to figure out the conjunction between what you did on the left-hand side and what you did on the right-hand side. And again, conjunctions are only true if they are both true. And you're going to notice there is no situation where the columns are both true simultaneously. And so you get a column of all falses, which makes this a self-contradiction. A tautology is the opposite of a self-contradiction. It is a compound statement that is always true. So when you look at the truth table, your final answer column will have all truths. If that happens, you are working with a tautology. So I'll show you an example of a tautology. On the left-hand side, the antecedent is going to be P and Q. On the right-hand side, the consequent is going to be P or R. So notice we have 3 statements in this problem. So when we create our truth table, we're going to have 8 different combinations. So we need to come up with P, Q, and R to start this problem out. Then we'll need to figure out the left-hand side, which is P and Q. Then we'll need to figure out the right-hand side, which is P or R. And then we'll need to figure out the conditional. If P and Q, then P or R. So let's work through this and see if we can discover our tautology. So for our P column, we will have 4 trues and 4 falses. For our Q column, we're going to have true, true, false, false, true, true, false, false. And for the R column, every other one. True, false, true, false. True, false, true, false. Okay, so now that we have that complete, we can develop the antecedent, which is the P and Q. So remember, in order for that to be true, P and Q must both be true. So we're going to get true, true, false, 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 false. Then we need to figure out the right-hand side. And the right-hand side, you have to do P or R. So remember, in an or situation, you just need one of them to be true. So in this case, we're going to get true, 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 false, true, false. And then last, we need to find the if-then statement. So we need to look at the antecedent first and the consequent second. And we need to look for any situations where we get a true and then a false. That is the only time the conditional is false. So we will have true, true, and we're going to have true the rest of the way down because the antecedent starts with a false the rest of the way down. And notice you get a column of truths. That is a tautology. Okay, another word they're going to use is what's called an implication. An implication is a conditional statement that's a tautology. So the consequent will be true whenever the antecedent is true. So let's look at this conditional statement and determine if it is an implication. So on the left-hand side, we have P or Q and not Q implies P. So we only have two statements that we're dealing with. We have P and Q, so that'll only make 4 possible combinations. So we'll then have to figure out P or Q, and then once we have that, we'll have to figure out not Q. And then once we have that, we'll need to do the and statement between them, P or Q and not Q. And then once we have that, we'll want to see if this implies P. Okay, so our possibilities for P are true, true, false, false. And then for Q, we're going to alternate. Then to figure out P or Q, keep in mind you only need one of them to be true. So this will be true, 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 false. For not Q, that is going to be the opposite of your Q column. False, true, false, true. And then for the conjunction of P or Q and not Q, remember for the conjunction, you need them both to be true. So we are going to get a false, true, false, false. Now, we're going to use this column and the P column to do the conditional and see how it goes. Now, remember, the only time the conditional is false is if the antecedent is false, or it's true, and the consequent is false. So, our antecedent is false, consequent true. That's a true conditional statement. Antecedent's true, consequence true. That is a true statement. Antecedent false, consequent false. True statement. Antecedent false, consequent false. True statement. So again, you got a column of T's, for a conditional statement, so that's a tautology. Since it is a conditional statement, it's also called an implication.